Greetings, everybody. We're going to continue our lesson in section 6.1 regarding ratios, proportions, and geometric means. And this time we're going to focus on the latter of that trio, geometric means. And what you're going to learn in this video, quite simply, is how to find the geometric mean of two real numbers. Now, before I really get into that whole conversation of how you find a geometric mean, I know that you know what this word mean is defined as, and you're used to thinking of this word mean as an average, and that's still going to be true about geometric mean, but there are different types of averages that you can take. For instance, there's what's called an arithmetic mean and, of course, a geometric mean that we're going to talk about. And these are each types of averages. There's also harmonic means. There are many different types of means that you could find between two numbers or sets of numbers. All right. Well, I want to compare geometric mean to arithmetic mean because arithmetic mean is the one that you know. You're used to thinking of a mean as being a number that's exactly in the middle of two other numbers, all right? Which is still actually true if you're talking about an arithmetic mean specifically. I'm going to give you a couple definitions here. First of all, how do you know if a number is an arithmetic mean of two different numbers? Well, a number x is the arithmetic mean of two numbers a and b if the following is true. If that number x minus a is equal to b minus x. All right? Now, let me give you an example. For instance, you know that 10 is the arithmetic mean of, let's say, 6 and 14. All right? Now, lots of different ways of describing it. Isn't 10 exactly in the middle of 6 and 14? But also, this is true, and this goes along with the definition that I gave to you. Because it's exactly in the middle, that means that 10 minus 6 is equal to 14 minus 10. In other words, if I was to arrange the two numbers and their arithmetic mean in numerical order, they would be equally spaced. 6 is as far away from 10 as 10 is from 14, right? They're both 4 units apart from one another. I could also say, for instance, that 30 is the arithmetic mean of 20 and 40 because, well, 30 is exactly in the middle of them, and 30 minus 20 is the same thing as 40 minus 30. Hopefully you get that idea. And you also know, by the way, that to find the arithmetic mean of two numbers, you just add them up and divide by 2, right? 20 plus 40 is 60. 60 divided by 2 is 30. Well, when we're looking at geometric means, we're looking at proportionality, it turns out. I'm going to write down this definition for you and then show you kind of how it works. A number x is the geometric mean of two numbers a and b if the ratio between the first number a and the mean x equals the ratio between the mean x and the second number b. For instance, if I'm talking about the numbers 2 and 8, 4 is the geometric mean of 2 and 8. Now notice how this is different than the arithmetic mean. If we're talking about the arithmetic mean of 2 and 8, well, if we add those up, we get 10 divided by 2 would get 5. 5 would be the arithmetic mean of those two numbers. But 4 is a geometric mean because this is true. The ratio of 2 to 4 equals the ratio of 4 to 8. Now the arithmetic mean is the one that got repeated in that proportion, right? So 4 is a geometric mean of 2 and 8. Both those ratios equal 1/2, don't they? Another example. 9 is a geometric mean of 3 and 27 because the ratio 3 to 9 equals the ratio 9 to 27. Both those ratios are equal to 1/3, right? But that number that I highlighted each of them, that's called the geometric mean. Remember the terms extremes and means? All right. Well, there's an example of a geometric mean. It involves proportionality. The arithmetic mean of 3 and 27 would have been 15, wouldn't it? That's the number exactly in the middle of the two. So I hope you see now how a geometric mean is different than the arithmetic mean. Now, how do you find the geometric mean of two numbers? Oh, that's what I'm going to work on here. And just to emphasize the whole geometry part of the geometric mean, I'm going to have us do this with distances, segment lengths. I'm telling you that this distance from C to D is the geometric mean of the distance from A to B and the distance from E to F. Well, according to the definition that I gave you then, that is true if this following proportion is true. CD is the geometric mean of AB and EF if the ratio of AB to CD equals the ratio of CD to EF. Notice that the thing that gets repeated here is the geometric mean of the other two things. Well, let's substitute then and solve that proportion. We would be saying then that 2 is to x as x is to 18. So then you cross multiply, you're going to get x squared when you multiply the means equals 36 when you multiply the means. And truly we would get two values algebraically for this, but let's focus on the positive square root of 36 here because we are dealing with segment lengths, aren't we? Alright, so x equals 6. 6 is the geometric mean of 2 and 18, isn't it? And you can kind of check that because you can easily say that 2 is to 6 as 6 is to 18, and that is 1/3 equals 1/3, so that's a true statement. Alright, so you can make proportions to find geometric means, but it turns out you can do a little quicker thing as well. I'm going to have you find the geometric mean of each of these pairs of numbers. In fact, I'd like you to go ahead and just find the geometric mean of 4 and 25 using proportions, but then after you've done that, pause the video. Well, pause the video while you do that, check your answer, and then come back and I'll show you a quicker way, a quick two-step process you can use with two numbers to find their geometric mean. Alright, now you set up your proportion to find the geometric mean, I trust, and you cross multiply, got x squared equals 100. And then you take the positive square root of 100. Alright, we could have taken the negative square root and it still would have been true, but we're going to say that 10 is the geometric mean of 4 and 25. Now, I hope you've noticed that we did the same two-step process there as we did in the previous example. I want to do a little derivation for you. If I'm saying that on number x is the geometric mean of a and b, that means that a is to x as x is to b, right? Well, when I solve that for x, every time it's going to give me x squared equals the product of those two numbers a and b. And then after you multiply those two numbers a and b, the next thing is that you're taking the square root of those numbers a and b. So, you know how you add two numbers up and divide by 2 to find the arithmetic mean? Well, it turns out that to find the geometric mean of two numbers, you always multiply those numbers together and then take the square root of their product. For instance, here 4 times 25 is 100. Square root of 100 is 10, right? Okay, so we can do that exact same thing right here with 5 and 9. It's just that it's not going to come out to a whole number, but that's fine as well. If we multiply 5 and 9 and then take the square root, we're going to find out that the geometric mean of 5 and 9 equals the square root of 45, which is different than the arithmetic mean, which would be 7, correct? And then if you like, you can go ahead and simplify the square root of 45. That's the same thing as the square root of 9 times the square root of 5, isn't it? So 3 square root of 5 would be the simplified radical version of that geometric mean. Alright guys, that's how you find geometric means. Thanks for watching. See you next time.